Hello everyone, welcome in. Hope y'all had a great holidays. Welcome to spring semester 2025. Folks in the right class, programming Python. Okay, cool. We're just gonna do a couple, syllabus day today. Just gonna introduce myself, just read the syllabus out, go over some little points here and there. And then do a bit of motivation. Some of you folks might have, this is probably your first programming class or your first computer science class. We'll do a little motivation so you can see what's kind of ahead of your career. I'm going to skip the icebreaker. This is a hybrid class. Normally I do an electronic icebreaker where there's like a poll and people can kind of see everything. I think most people are taking this as a recording. They're just going to watch the recording. So I'm going to skip the icebreaker. The whole goal today is to set up a development environment. So we're going to see if folks can log into your Cabrillo student emails. How many folks here can log into their Cabrillo student email? Okay, just a couple. All right, what could you all set up today then? But yeah, that's really the whole goal today. Just connect to something called JupyterLab. This is a server. So for this class, all you really need is a web browser. All right, you go to a web browser, you go to this site. This is a server hosted at the Cabrillo where we're going to do all of our programming. So yeah, that's really it today. We'll try to finish up lesson 1, assuming that folks can get into their labs. The website is jupyter.cis.cabrillo.edu. We're gonna have like an hour towards the end of class to get folks set up with this. But if you want to get a head start on this, you got to make sure to be able to log into your Cabrillo email. But yeah, we'll get that done in a bit. Let's do a bit of intro. So my name is Andrew Tack. I am from Yosemite, just a few hours away. I started at Cabrillo and then went to UCSC to get a couple more degrees. But both of the degrees were in computer science, mostly artificial intelligence concentrated. I got a bunch of research and a few internships in San Jose. Let's see, current hobbies, just building computers, programming AI. Previous hobbies, let's see, I don't really have time for this stuff anymore, but I still kind of do play video games. So yeah, just a little bio sketch. All right, let's go over the syllabus. I'm just gonna read some small points here. On the Canvas homepage, there's a daily schedule. These are the times when I'm on campus, so you can kind of catch me wherever. It shows where I'm at all times. Just not at home though, it won't say that. There's the weekly schedule right here. You might find yourself clicking this a bunch. It's gonna show the every single week breakdown. For example, on week 1, we'll do a little intro to Python. It consists of 2 lessons, 1 and 2, and then 1 lab, and then a project due the following week. All right, we'll talk about these labs and projects in just a bit. Then fast forward, we have a midterm, then we got spring break, and then we got a final. All right, so you might find yourself clicking on this a few times. This is a hybrid class, so you can be in person, Zoom, or you can watch this YouTube playlist, whatever floats your boat. I got a bunch of office hours and STEM hours. Has anyone been in the STEM before? STEM. Okay, sweet. Yeah, it looks like a few of you guys have. If you haven't, the STEM is this building over here. It's a really big building. You'll find a lot of people doing homework, like math homework, engineering, any of the sciences. that is a really good place to kind of get stuff done. But when I was at Cabrillo, I went to the STEM a lot, and that's pretty much where I did all my homework. Because they got tutors, lots of resources to help folks out. And my office is right over there. Just it's the next building. Well, I mean the next room over. So if you're trying to catch me in office or STEM, I'm usually bouncing back and forth. I usually go to the STEM for public helping, and I go to the office for private matters. So yeah, just you might want to go back and forth. Super accommodating and flexible. If anyone wants to meet on Zoom on any other times, feel free to contact me. I'd be happy to meet, even on the weekends, even at midnight. Okay. There's only two pieces of grading in this class. It's the projects and exams. Right? The projects, there's a weekly one, and the exams, there's two. There's two exams. The projects, we'll talk about that in a bit, but the late penalty here is 5% a day. I do accept regrades, so if you turn it in before the deadline, then I can help regrade it and give some helpful feedback on how to kind of fix things up. There's no textbook. These are just optional. Most of the classwork is on the server that we'll get connected to later. Extra credit, this is for students with active contributions in the discussion forums. There's some discussions here. Whenever folks have a technical question, I recommend asking it in the discussions. This way the whole class can see it. If you private message me on a technical issue, most likely I'm just going to copy and paste it into the discussions and answer it publicly. All right, as for resources, we got tutors. All right, we got the STEM Center tutors right next door. We got the CTC right across the street. CTC also has tutors. They got laptops to lend as well. And for some accommodations, make sure to visit the Accessibility Support Center. All right. Okay, academic integrity. This pretty much says don't cheat. Not many people do, so it's all good. Let's see, contact info. My email is right here. You can email me on Canvas as well. I think I prefer email instead of Canvas because email has nicer format. Like you can bold stuff, you can write in different fonts. That's it for the syllabus. Any questions about that stuff? Yeah. Yeah, good question. What's our server? Yeah, our server is compatible with all laptops. You actually just need a web browser. We have computers here, by the way. So if folks are in person, you can just lift these up. And there's some computers. The on button is somewhere down here. Somewhere here. And the password is right here. So it's gonna be student and then Cabrillo. But Cabrillo is spelled differently. Yeah. Exactly. Nope. Yeah, in this class, we're only gonna connect to a server, which is gonna host every single thing for us. Right? You don't have to download any dependencies. You don't have to download a text editor, no compiler. Right, so yeah. You can access the server from anywhere. Yeah, anywhere in the world, I think. Mhm. Mhm. Huh? Yeah. Yeah. Yeah, Jupyter The server, we'll talk about it in a bit. It's a development environment that contains a text editor, the runtime, and all the dependencies that's required. But yeah, that's a good question. For this class, we don't need to download VS Code nor BBEdit. For folks who don't know what those are text editors. Yeah, we don't need any of those. However, in other programming classes, there will be a different pipeline. In my other C++ classes, I have everyone install their own development environment. So most people will be downloading VS Code and a compiler, but not for this class. This class is meant to be, it's trying to be seamless. So you don't need many resources to access this. Huh? Yeah, at least the problem-solving concepts will carry on. Yeah. Yeah, Benito.
I have one question.
Yeah.
There's another like introductory Python class, right? Like, what's the difference between like the CIS 15 and like the other one? I forget the number, but like intro to Python.
Yeah, good question. So that's really a difference between, what's the difference between computer science and computer information science? We do have two intro Python classes. All right, so computer information systems, CIS, this is meant for like technology and business. So it's kind of more like a broad overview of things you can do. In the computer science, that is like almost pure software engineering. Right, so it's closer to algorithms, it's closer to problem solving. And yeah, yeah, that's a good question. Yeah. Oh, the computer science one? Yeah, that one is for like software engineering, algorithms, problem solving concepts. Hmm? Yeah. Oh, yeah, this class can prepare you for the intermediate Python. Yeah, but we do have two intro to Python classes. All right, we got a CIS and a CS one. So. Yeah, good question. Difference between CIS and CS. CIS, in short, I think of it as like technology and business. It gives you a broad overview of maybe the IT stuff, and then computer science is closer to software engineering. It'll help you get closer to being a software developer. Yeah, but both are good. Both intros are fine. It just depends on what you're concentrated in. So yeah. Oh, it's all good. Yeah, there's tons of overlapping between the two programs. I think the biggest overlapping is programming. Yeah, programming and learning how to solve problems. Yeah. Oh, do they use anything to validate code? Yeah. Yeah, good question. So someone asks, will our projects be validated in some way? So some of them are. So some of them have a auto grading thing at the bottom of it, and you can pretty much verify whether or not your solution was correct. All right, some test cases. Yeah, good questions. Yeah, well, we'll talk more on the project in a bit. But any general questions about, maybe CIS, CS, or anything about the syllabus? Okay. All right. Someone asks in the Zoom. Hi, Andrew. Am I recording? Yeah, I'm recording. I'm using a different software to record, actually. Yep, I'm recording.
Thanks, Ray.
Yep. All right, let's move on. Let's talk about some motivations. Some of you folks, this is your first programming class, so let's do a bit of motivation. Computer science, computer information systems. This spans like so many different areas. We're only going to touch like a few of them. Right, so some of you folks might be here for maybe game programming. This is a very popular major that I've seen. Cabrillo has offered some game programming classes in Java and C++. I'm not sure we offer them anymore, but if folks are interested in game programming, please let me know. I'd be happy to bring it up to the dean and say, hey, we want to teach this class. So yeah, there's game programming. You can also make AI stuff. That's what a lot of people are doing nowadays. They're programming AI in games to kind of maybe play for them. Some folks might be interested in full stack development. One way of thinking about this is like a website, where you got kind of two ends of it. You got the front end, which is the person meant to make things look nice, and we got the back end, the person who's meant to maintain the databases, make sure everything in the background is moving smoothly, so the person on the front end can do their job. So people might be interested in that stuff, web design. Yeah. Yeah. You could think of front end as UI, UX, user interface, user experience. Yeah, good. CS and CIS also spans cybersecurity, right? I think some folks here are into cybersecurity, like Benito. Benito's in cybersecurity, right?
Yes.
Yeah. Did you want to make a pitch on your club?
I guess so.
Yeah.
And Jeremy, you gotta stand up too. All right. So we do have a cybersecurity club on campus, actually. So if you guys are interested in learning cybersecurity at all, we're super welcoming. We love new members. Maybe join us this year. Nice to see you again. But yeah, we do a lot of things. We meet Mondays, 3:30 to 5. Can't make that time though. We do have a lot of other meetings and events. We do movie nights, we do bonfires, we do panels, we do field trips, we do data center walk. We do like a ton of stuff. We're just trying to get the community together. Not all of our events are related to cybersecurity. A lot of them are also just like random stuff. So yeah, it's a cool club. We meet in the networking lab as of right now, but we might move that. So, anyways, if you guys are interested, just come say hi to us and just get to know you guys. So, thank you.
We also have a Discord that's like the best way to keep it happening. I'm not sure. Yeah, I'm not sure how we can show you guys, but once it's up, you'll see flyers everywhere, literally everywhere.
You will see flyers. So, flyers.
Cool. Yeah, for folks on the recording, there was a pitch on the cybersecurity club. I'll make an announcement on Canvas. So yeah, Benito, just send me over something I can copy and paste. So yeah, good old cybersecurity. A little off-topic thing. Has anyone heard of the Las Vegas hackers from last year?
Yes. Yeah.
Uh-huh. Oh yeah. It was like a ransomware. I think they got the MGM properties for like, I don't know how many million, but
it was a social engineer attack too.
It was like, hey, what's
called saying it was like the most basic thing. It was like, hey, I'm IT.
Damn, yeah. So it's crazy. Yeah, that's crazy.
Do you teach the cybersecurity?
I do not. I think someone else teaches cybersecurity and ethical hacking. Yeah.
Great classes, by the way. They're very interesting.
Mm-hmm. Yeah. Yeah, cybersecurity was actually my first major, and then I switched it to computer science. Cybersecurity. I'm not sure we'll touch cybersecurity, but you might be able to apply some concepts towards it. But always feel free to let me know during office hours. I'd be happy to go over this stuff. In my C++ class, I do go over cybersecurity because C++ is a little closer to the machine. Yeah. Robotics. We're using Python in robotics right now. So for folks who are interested in the Friday robotics club meetings, you might be able to join their software engineering team. Right? They got a bunch of teams. They got hardware, they got software, they got marketing, and a bunch of other positions. But right now I'm advising for the robotics, mainly for the engineering team. I mean the the software engineering team. Computer science and information systems also spans something called data science, artificial intelligence, machine learning. This is a very trendy topic today. It's super trendy. These job markets are, there's a lot of positions in AI stuff, right? Yeah.
Like in every job every single one I've seen has like now I've seen that they've added the little AI/ML
Mhm.
or whatever. It's not even closely related to that. Like it's like the most basic IT job. So I'm wondering like what's the big fuss about this?
Right.
Why is this a big trend right now?
Is it like the requirements or the qualifications?
Requirements, preferred, whatever. It's
Yeah.
like it's a wish list, obviously. They all have that AI/ML.
Yeah.
Preferred or whatever. I'm like,
right? Yeah, a lot of job positions are seeking people who are having some data science skills. Towards the end of this class, we'll see some stuff on data science, where you take a large amount of data and you can kind of predict things based off of it. But yeah, a lot of jobs require it. I think just because computer science is a historically impacted market, so in order to have a more competitive edge, knowing some things about data science will increase that edge. Yeah, good question. What's data science? In short, I would say it's analyzing a bunch of data. You can think of it as Excel spreadsheets, but in a more uh, in a more predictable way. Like you can use equations, take a bunch of data, and then make predictions based off of it. Yeah, right here, data science. It's got overlaps with machine learning and statistics. For folks who are not sure what machine learning is kind of like making an algorithm adapt to a scenario, and that algorithm can predict things a lot better. AI is a trendy topic nowadays. A lot of people kind of just use AI synonymously with all of these terms right here. So if you find yourself in a conversation about your interest in AI, it might be a good idea to clarify what about AI you're interested in. Right? Like maybe you're interested in autonomous vehicles, or maybe reinforcement learning. Uh, just an off-topic thing. Reinforcement learning is like it's like training a model to do things better. Has anyone seen the Super Mario AI that would kind of beat a level faster than any human? Yeah, if you did, that's pretty much a reinforcement learning. They train Super Mario over a million different iterations, right? And then after the million iterations, Super Mario was able to beat a level as the world record. Yeah.
this is kind of going back to the video game program.
Mhm. Wait, replicate names?
Replicate games where like so you don't actually
Uh-huh. Oh, good question. Yeah, good question. I'm not sure. Yeah, I'm not sure how the new Call of Duties are
just do games
made.
in general. Like,
Yeah.
Somebody use ChatGPT to
Uh-huh.
build a game.
Yeah.
Like can somebody actually do that? Use ChatGPT, but I'll validate it.
Maybe. Yeah, maybe. Yeah. I think it'll be very limited though. I'm not sure if ChatGPT can make a whole AAA game.
I know
Yeah.
somebody who not a game.
Yeah.
I know somebody who developed
Yeah.
inside.
Uh-huh. Impressive. Yeah. Yeah, a lot of stuff about AI. I'd be happy to talk about this stuff. This is one of my favorite subjects. So yeah, that's a bit of motivation, right? Like CIS, they span a lot of different areas. Whatever you're interested in, it probably touches it. I'm also leading a couple of research groups for folks who are interested in joining a UCSC research lab. That there's some opportunities to kind of pipeline you to it. Feel free to let me know if you're interested in this stuff. This is an extracurricular activity. It meets 1 hour every week for 5 different weeks. And pretty much what it is this exploratory reading groups. We do activities that the UCSC professors are requiring. So if you want to join a UCSC research lab, there's some opportunities for that. You just let me know what your interests are, and we can get you hooked up with whatever professor has that topic. Not necessarily a transfer program, more like qualifications to enter their lab. Speaking about labs, let's talk about the server that we'll be connecting to. There's something called JupyterLab. This is a development environment that we'll be doing 100% of our Python programming in. All you need is a web browser and a Cabrillo student email. I'll talk about what JupyterLab is in a bit. Let's spend like maybe 15, 30 minutes getting folks connected. So we're gonna need to, you might have seen this in my welcome email. Basically, you wanna be logged in to your Cabrillo student email and then log in to the jupyter.cis. To log into your Cabrillo student email, you want to go to google.com and then click here. Click here and then add an account. There's an add button somewhere. So make sure it's not your personal email. Cabrillo student email. There's some tutorials on how to log in to it. You want to go to the Google login page. The username is your ID at student.cabrillo.edu. Password is the same as Canvas. Let me know if you get an error. Some folks might get errors that says, please contact your domain administrator. If you get that error, you're gonna have to go reset your password in some other place. But yeah, let me know if you get that error. All right, I'm gonna pause the recording here and give folks some time to log in. Looks like most of us got connected now. If you got connected, the JupyterLab looks like this right here. It's a development environment. On the left, if you click on this folder icon, it gives you a file explorer. Right? It shows you folders and files that you can kind of go into. In particular, we're going to visit the lessons. So click into the lessons folder, and we'll be doing number 1, getting started. So just double click it, and on the right, it should open up something called a notebook. Getting started. Okay, I'm going to close this file explorer now. Just talking about notebooks a bit in the development environment. A Jupyter Notebook is an interactive development environment. This is not really like classic Python coding. This is more like it breaks it up into different cells, and you can press the play button on different cells. In my opinion, traditional coding is, you're writing a file, you're writing a whole file of source code, and then you're running it. All right, but in this case, we have a notebook with cells, code cells, and you can type runnable code in the cells and press the play button. All right, so it's a little different, but basically the reason why we're using notebooks, it allows us to kind of visualize each and single step, and also kind of run single lines at a time. Right? It's a good learning tool. Towards the middle of the semester, I'll go over more traditional coding, traditional Python coding. But for now, we're going to stick with this development environment. There's a few different types of cells. There's a text cell and a code cell. Sometimes you might find yourself accidentally double-clicking a text cell. Right? Like, let's say I accidentally double-click this text right here. Right? See, I accidentally went into it, and people might be wondering, "Oh, what is this?" This is just it's called Markdown. Actually, it's like HTML. We don't need to know Markdown, but if you accidentally click into a text cell, just press the play button. All right, pressing the play button will render this cell. So I'll press play, and it'll render it. All right, we're gonna just be focused on the code cells. Are people cool with this so far? Okay, cool. Hello world. Hello world is kind of an analogy to make sure your environment is working. In a lot of languages, typically the first programming assignment is some sort of hello world thing, which kind of verifies that your environment is working. So to verify it, we can do a print statement. Right? Python has a function called print. And functions can have inputs. All right? In this case, the input will be inside of these two parentheses. All right, I'm just going to input a hello world. And we got to make sure that the hello world is encapsulated in quotes. All right, the quotes signify that we're going to be writing text. All right, if it weren't for the quotes, you're probably going to get some error message, which we'll talk about later. All right, so make sure you can run this, press the play button, and it should print hello world. That should verify your environment is working. All right. You can edit this, right, and rerun it if you want. Like, hello world, how are you? And just rerun it. And it's just going to change the output. All right. People cool with this so far? Good old hello world. Okay, cool. A common error might be missing these parentheses. Right? If we don't have the parentheses, what actually happens is Python will think that these two are variables. Right? We're not talking about variables yet, but you're probably going to get some error. It says, "Oh, invalid syntax." Let's just try to print one, right? Let's just try to print hello. Right? You're probably going to get some error like hello is not defined. Right? But basically, it's treating this as a variable. We haven't covered this yet, but we want to print the literal text in quotes. Okay. Okay, you can print multiple things, right? In programming languages, there's something called statements. So we can put series of statements together. In this case, we're just going to print two things. Right? I recommend typing it out yourself instead of copying and pasting. This way you can kind of get the muscle memory of parentheses. I recommend whenever you open a parentheses, just close it right away. Right? So close it right away and then type in your stuff here. All right, once again, I'm going to open some quotes and close it right away. Right, this is a good program practice because if you don't close it right away, there's a chance that you might miss the second one later. So I'm just going to type roses are red, right, and then another statement, another print statement. Violets are blue. and then just run it. So press the play button here, and it ran the 2 print statements in order. Okay. There's something called comments. This is text that is non-runnable code. Right? For example, so this is runnable code right here, right? Print hello world, right? This is runnable. If we prefix a line with a hashtag, it'll make it non-runnable. Right? You might be wondering why we do that. So I'm gonna put a comment here, press play. Right? It doesn't do anything, right? Because this is no longer runnable code. One reason why we might use comments is to document code. When we have more complex programs, it might be useful to tell what the program does. Right? So for example, this program prints hello world. Right? This, in my opinion, is not really a helpful documentation, but as our programs get more complex, the comments will really help out a lot. So prints hello world. Are people cool with comments so far? Another reason for using comments is to disable lines of code. Sometimes you might be writing longer programs and you might have like a bug somewhere. And it might be useful to kind of comment lines of code out. Right? This will kind of help you pinpoint where things are going wrong. So yeah, lots of uses of comments.
So there's other ways to comment.
Yeah, there's a couple other ways of commenting too, like a triple quote. This is like for a multi-line comment. Oh yeah, good question. Not necessarily the hashtag. Python uses a hashtag for comments. Other languages might use a different symbol. Yeah, a couple other languages uses the hashtag as well. For folks, have folks here heard of Bash? Okay.
Kind of forgot though.
Oh, okay. It's all good. Yeah, in Bash they also use the hashtag. In C++ they use they use this right here, two forward slashes. But yeah, in Python we use the hashtag. There's another one too. It's a, if you want to do a multi-line, you can use, I think, triple quotes. So you can say print hello world. Right, this is for multi-line comments. So that's one way. All right, people cool with this so far? Good old comments. Okay, cool. All right, let's talk about expressions. This is where we kind of do a bit of math. We'll do more math on a Wednesday. We can do numbers. Right? We can type in numbers and kind of see what they evaluate to. Right, like just 5. 5 evaluates to 5, which makes sense. 5 plus 5.5. This is 10.5. We're kind of using Python as a calculator here. One special thing about a Jupyter notebook is it shows the value of the last run expression. Right? When we press play, this number isn't actually being printed. It's actually just showing the value of this last run cell. Right? For example, if I were to do 2 plus 2, right? Let's see what happens. So I have 2 statements here. Right? It's actually, they're not really statements. These are 2 expressions. Right? So I'll run this, and it prints 4. Right? Once again, it's not really printing. This is a Jupyter Notebook thing. It'll show the value of the last run statement. If we were to explicitly print them, then it should turn them into statements. All right, so I'll print both of them, and it's going to print both of them right there. So yeah, we're going to talk about this a bunch of times. Okay. Just to kind of reiterate that, well, what do you think is going to happen if I do this right here? Print 50. All right, what do you think is going to, what do you think the output is going to be? Let's run it. It just prints 50. Right, because these two are expressions. They're not really being printed, but the last one is a statement, and it actually explicitly prints it. So these two aren't really being ignored. They're being computed, but they're just not being printed. Are people cool with that? Okay, so yeah, we can do expressions. Right, there's a bunch of expressions here, a bunch of math we can do. All right, 1 divided by 2. We can do a bunch of different math. But we'll talk about math next week. I mean, on Wednesday. We can do expressions with something called strings. Right? A string is like a literal text. So you can do hello and then add world to it. Right? This is called concatenation, a fancy word of saying adding text. So we add these two texts together, we get hello world. Just they're concatenated. You can keep adding more things, like maybe add a space. Right, so add a space, and it should put a space in between. Okay, cool with this so far? Yeah, these are strings. They're text that's wrapped in double quotes. Yeah, strings are not numbers. Yeah, these are still considered expression. So the Jupyter Notebook is showing the result of the last expression. In my opinion, you should actually explicitly print this. Okay. All right, let's move on to some more statements. We've seen this earlier. We can do multiple statements that kind of go in a certain order. So if we were to print all of this, it's just going to print all of them in that order. So run this, press play. Okay. All right, let's talk about a bit of functions. One of the first Python functions we'll see is something called a length function. Right, we'll see more later. So there's a function called length. In Python, they use len, right? Length. A function, as you might see in math, it can take input. Right? We pass it an input, and it produces an output. In this case, the input is within these two parentheses. So if I were to put an input like a string, right? Hello space world. This string or text is the input, right? And the result of the function will be some output. Right? In this case, the output is 11. People know where that number came from? Yeah, number of characters. Yeah. Oh yeah, number of characters, including the space. Right? A space is a character. So you might be wondering, oh, why do we need a length function? In the future, we're going to be dealing with data structures. It will be necessary to calculate the length of a certain data structure to kind of see how big it is. You can do length of more things like hello plus world. Right? The input is this expression. Right? This expression evaluates to a single string. Right? What do you think the length of this would be? Yeah, just 10, because we took out the space. Right? And you can print it. I would print it to be more explicit. Yeah. Oh, yeah, good question. There actually is no space. Yeah, this expression. All right, if I copy and paste this expression, let me just make a new cell. Just gonna make a new cell. This expression evaluates to hello world with no spaces. So that's why there is no space. Yeah, good question. Are people cool with this so far? Some intro to a bit of functions. Okay, cool. Something called class functions as well. It's a different type. It's I like to call them dot functions. So a string is kind of a special object in Python. We'll talk about objects in a bit. Basically, an object is something that has access to dot functions. For example, if I say a hello world, this is a string, right? It has access to a lot of different functions, like upper. Okay, so this evaluates to just hello world in all uppercase. This is different from the previous types of functions that we've seen, right? Previously, you might think that you can just type in like upper and then hello world, but this is not going to work because upper is a special function that belongs to a string. So the proper way of using this upper function is the dot notation. These are not stuff you have to memorize. There's a lot of different string functions or methods. You can look this stuff up. Like if we type in string methods Python, we can go to the primary documentation. Primary documentation is right here, the docs.python.org. And there's tons of methods we can use, right? Like we can use a dot capitalize. It returns a copy of the string where the first character is capitalized. Right, so let's just use that. Hello world dot capitalize. Right, run this, and it capitalizes the first letter. Right, this is a expression, by the way. So I would print that expression to be more explicit. Right, so there's lots of different functions. Right there, you see how long this is? There's so many different things you can do. Let's do one more. Something called a replace. Right, let me just look at the documentation real quick. So replace. Okay, string.replace. It returns a copy of the string where something is being replaced by something. All right, let's just use that real quick. So let's say I'm just going to use hello world. Hello world. This is a string that has access to a method called replace. This replace function or method needs to take a couple arguments. We can see that in the documentation as well. This documentation, there's a couple arguments. There's one called old and one called new. So the old, I'm just going to say the old is hello, and then the new will be hi. So the result of this expression should take these two arguments, do something with this string. It says hi world. All right, people cool with this stuff so far. All right, so we just covered a couple of different types of functions, right? It might seem like a lot right now, right? We covered one type of function. That these are not class functions. I know we haven't talked about class functions yet, but basically these are not dot functions. And then we also covered dot functions down here. Right? There's a couple of different types. We can compound functions together. So if we were to copy and paste this expression, right, hello world dot replace, I'm just gonna copy this, right, and then compound it with another one. So at the end of it, I'm just gonna put dot upper. Right, so this is kind of combining two different things. You will see what's happening here. It replaces it and then uppercases it. Right, lots of things we can do. Yeah, this is some cool stuff. In some classes, you can actually complete a whole program in one single line. It's gonna be a really long line though. All right. You don't have to know this stuff. Whoops, let me delete this. You don't really have to know this stuff yet, but this is kind of just a sneak peek into the future. Right? In the future, we're gonna see some stuff on if statements. So you might see this right here. Right? This code block grabs the current time, and based off that time, it'll greet. Right? It'll greet good morning, good afternoon, good evening. In this case, it's going to print good evening. Give me 1 second. My projectors are glitching. It's actually not evening right now, by the way. It should say good afternoon, right? Yeah. There's actually a couple things off with this block of code that we're going to fix. First of all, it's not evening. If you're wondering why it's printing out good evening, we could kind of do some debugging statements. Maybe we should see what this is, this now. Right? This is a variable. Or, yeah, you can think of it as a variable. So let me just print now, right? Print. Oh, no, not as a string. Right? If you print it as a string, it's going to print literally now. Right? What I meant to do was print out the result of this. So not within quotes. And so I'm just going to print this. Print now. You can kind of think of this as a debugging statement where we're printing the value of variables to see what's going on wrong. So let's see what's going on wrong. Is this the time? No, it's not the time. It's not 23:55. This is using a different time zone. It's using something called the UTC, the Universal Time Zone. So if you're curious what's happening, the time zone, the UTC is right here in the middle. West Africa. So it's like midnight there right now. Our time zone is right here. It's -8 from the UTC. So one way you can fix it is kind of just subtracting 8 hours from it. Right? But let's pretend that we're just dealing with a UTC, right? Let's not focus on time zones because that's a little different. So first of all, or second of all, there's a little error right here too. Right? This shouldn't be 5. Right? Well, what should it be? Or actually, here, you know what? Let's do one more thing before we even talk about this 5. Let's convert this to Pacific Standard Time. You don't have to know this for the class. This is just a little sneak peek, right? You really don't have to know this. Let's just convert this to Pacific time. Once again, you don't have to know how to do this. I'm going to import something called time delta. Time delta gives us a module that allows us to shift time zones. So I'm going to shift the time zone by 8 hours. And once again, you don't have to know how to do this. I'm just shifting the time zone. Okay. So now I printed out the value of this. Does this seem like Pacific time now? Yeah, 1557. Yeah, I think that's the time zone right now. It's not evening yet. Do people kind of see what's happening here? It's not evening. It's actually still afternoon. All right. Well, what do we do to fix this? Yeah. This should be in military time. So it should be a 17 instead of a 5. If people see what I mean? 17. Okay. So there you go. And now it says good afternoon. Okay, this did seem like a lot. All you really got to take away from this is print statements. We're using print statements to kind of debug what's going on in the program. Right? You don't really have to know this time delta stuff, these imports. They're just a print statement to debug things. Yeah. Uh-huh. I kind of snuck this import in here right here. So yeah, it's all good. I snuck it in real quick. But yeah, I did a comma, time delta. Yeah, which imports a module that allows us to shift the time zones. All right. Okay, let's talk about import statements. Oh, actually, no. Are there any questions about this so far? Just really print statements. Yeah, no questions. Anyone on Zoom? All right. By the way, I forgot to mention this. You might want to save your notebook. There's a save button right here, top left. I think Control S works as well. If you don't save your notebook, refreshing the page will make you lose progress. All right. Let's talk about import statements. We're going to be introduced to a library that helps us visualize algorithms. This is like turtle graphics. Right? We're going to be using graphics, but a turtle. Right? There's going to be a turtle that moves and kind of has a little poop trail. This library is called JupyterTurtle.turtle. So we're going to import that and then press play. All right, so we pressed play. It didn't output anything. It did do something though. Right, see, it says 40 here. If you're wondering what this number 40 is, it's just saying it's the 40th statement that we ran in this program. Right, I can run this over and over again, and then it will just increase the number. Right, all I'm doing is rerunning this, so it's importing over and over again. Okay, we imported this library and we gave it another name called TU, for short for turtle. If you're curious, this library was written by Mike Matera. Has anyone taken a class with Mike Matera? No? Okay. Let's visualize what this library does. The first statement we'll do is something called a .new. Right? So tu.new. This is going to create an instance of a turtle. So tu.new will run it. And it gives us a canvas with a single turtle just floating there. Okay. Let's see what else we can do. We can make it move. Right? There are some class functions that TU has access to. Right? For example, we can do tu.move 100. Right? It should take this turtle, move it in its current direction. Let's see what happens. I'll press play. All right, so I pressed play and scroll up a bit. We see that it kind of controlled the canvas, right? It moved it up a bit. We can keep doing some more stuff, like tu.turn. I think it's going to be off the canvas now. I'm going to press play here. I got to scroll up again. Yeah, it's off the canvas. So what happened was it moved it up 100, and then I reran this cell. So it actually moved it up another 100, and then turned it 90. Let's restart this. I'm just going to rerun this new cell, or this will recreate the turtle instance. Okay, so I just reran that. Now I'm going to run this cell again, move 100 and turn 90. So I'll run that, press play, scroll up a bit. Right, we see it moved up and then it rotated 90 degrees counterclockwise. Right, we can run this over and over again. Here, let me zoom out a bit. I kind of don't like how whenever we press play, it kind of just throws you in a different part of the notebook. But you can run this over and over again. Right? If I run this cell again, it should do the same thing. Yeah, so I just ran it. Right? It moved it 100. Yeah. Oh yeah. Is it off the canvas?
Yeah, it's still off.
Oh, you might want to rerun this cell. So I reran this new cell to kind of start the turtle from scratch. Yeah, so start turtle from scratch and then run this. I'm going to run this over and over again. All right, so I just ran it 4 times and it kind of drew a square. This is kind of getting annoying, kind of scrolling up and down a bunch. In my opinion, I would probably do this together in the same cell. So let me just create another cell to kind of do that. You can create another cell by clicking this plus button here. Right, so I'll press plus, and let's just start from scratch. You got a nice, a square, right?
Oh no, I got a rectangle.
Oh, interesting. Okay. Yeah. Nice. Yeah, you can create a lot of different shapes. All right, let's create some different shapes here. I'm going to start from scratch, meaning I'm going to create a whole new instance of a turtle. Right, I'm just going to say tu.new. I'm just going to let me comment this. A whole new instance. So I'll make a tu.new, and I'm just gonna keep it in one cell. This way, you don't have to scroll up and down a bunch. All right, tu.new, I'm just gonna keep it all here. All right, so tu.move 100, tu.turn 90. Here, let's actually do a rectangle. So I'll do a rectangle like someone did earlier. So move it up 100. Okay, if I run this, right, it does the same thing. Right, the difference is when I rerun this cell, it's gonna start over. Right, see, I'll run this cell, and it starts over. Right, hope that makes sense because every time we run it, it's creating a whole new instance. Right, so let's just continue drawing a rectangle. Right, a rectangle. I'll probably just move it like 200. Tu.move 200, and then tu.turn 90 again, 90 degrees clockwise. By the way, I'm inserting this vertical white space here to make things look a little more readable. Right, you don't need this extra new line, but can folks kind of see how it makes things more readable? Okay, cool. So I'll run that, and there we go. We're almost done with a rectangle. Right, we just gotta, what do we have to do next to complete the rectangle? Yeah. Right, we can probably just get by copying and pasting this. Right, meaning that it's gonna move 100, turn 90, move another 200. So I'll go ahead and copy and paste this. It should draw a rectangle. People all good back there? Nice. All right. The whole point of this code block was to show we can put everything in one single cell. Every time we rerun this cell, it's going to start from scratch. Earlier, we kind of had to scroll up and down and rerun code blocks over and over again. But yeah, you can just do that in a single cell. All right, any questions about moving a turtle so far? All right. We're going to run into some bugs. Let's see this following. There's a bug. Let's see if folks can fix it. The goal of this cell is to draw a square. How do we fix it? Yeah. Oh, yours doesn't show on the bottom? Okay. Okay. Let me take a look. Did you guys run it? Oh, okay. Yeah. Here, let me take a look right now. Right. Oh, okay. Oh, yeah. It looks like it's actually itself. I was trying to dig at the bottom. All right. Now let's get back in it. That's pretty much it for today. Yeah. Someone in the Zoom chat says it looks like the turtle moved more than 100 on step 4. It should just be the 80 degrees thing. So we changed an 80 degrees. I think it was this one right here. But it should be moving 100 though. Oh, on the original image. Yeah, on the over here previously we wanted to draw a rectangle. Just out of fun. That's why we moved it at 200 instead of 100. Yeah, this is just for fun, this previous cell. All right. Are people cool with this so far? Just some debugging, moving and turning. Yeah, what's your name?
Oh, I'm George.
George? Yeah, what's up, George?
Oh, no, I got nothing. I just need a thumbs up.
Oh, sick. Okay, cool. Yeah, someone gave a thumbs up. Cool. Yeah, that's about it for today. Yeah, we just. Oh, okay. Hold up. Let me get to someone in the Zoom. So someone in the Zoom. Someone in the Zoom made this on accident. Let's see. Yeah, this looks like. Yeah, we'll have to see your code for this. Um, most likely is in your. It's in one of your middle statements. The moves should look like 100 and then turn 90 4 different times. Yeah, I'm not sure how you generated this, but most likely it's from moving too much. I think if I were to replicate that.
It's on the last move.
Yeah. Somewhere right here.
Second to last move, and it's not replicated.
Okay. Oh, okay. Looks like person. Yeah, Joe. Nice. Looks like you got it. Cool. Nice job fixing it. These will happen, right? You'll get bugs in your program. And part of programming is to debug it, right? Figure out what's going wrong with your program and fixing it. That's probably like 70% of programming. All right. So let's do some concluding thoughts about today. We finished the syllabus, motivated what areas computer science and information system cover. For most people, we set up the JupyterLab environment. If you're on the recording and having a bit of troubles, please reach out and we will get you all set up. Finish lesson 1. All right, lesson 1 on getting started. Right, all we really covered in lesson 1 were print statements, a few different types of functions, and an intro to a library called Turtle. This Turtle is going to help us with next lecture, where we visualize algorithms step by step. For a head start, if people want, you can look at the weekly schedule. The whole goal of this week is to cover lesson 1, lesson 2, and then lab 2. And there's going to be a project that's due next Thursday. Basically, this project will be using the turtle to draw a specific shape. But if you want a head start, you can look at lesson number 2 and the next lab. Someone in the Zoom asks if we need to turn in this lab. No, we don't. This is not a lab, it's a lesson. On Wednesday, we're going to jump into this labs folder, right? It's not a lesson, so jump into the labs folder, and then we're gonna go into lab on the algorithms. So we're gonna do this on Wednesday. This is really just practicing using the turtle. This will be turned in. It's required to turn in. But yeah, we'll cover the lab on Wednesday and then the project. If folks want to see the deadlines, you can click on the assignments. And there's a couple assignments out right now. There's lab week 1. This is due on February 7th. This is the end of the week. I think it's Friday. So yeah, Friday. You should be able to get it done in class on Wednesday. And then project week 1, this is due next Thursday. You should be able to get this done over the weekend. It's using the turtle to draw a certain shape. All right, so that's about it for today. Nice work, everyone, on getting your development environment set up, and I hope to work with you all. See you guys.